Make sure you watch this whole video because it's good for external exams. They often switch up galvanic cells. It's also good for your SE about justifications of modifications to do and why, and also errors. And so it's probably worth it could be worth more than 5 out of your 100 ATAR marks just by watching one experimental video. It's also good because shows how AI falls short. It can't do experiments, can't prove it, can't test it. And your teacher can't do this in class. There's just too much going on. There's too much to set up, too much to do within the limits of how many hours you have. So it takes many, many hours to put this together, and it only takes 5 minutes. So first of all, make sure you test all your equipment because we're delving into physics here. So if it moves, it's bio. If it smells, it's chem. If it doesn't work, it's physics. So what I'm doing here is I'm first calibrating the equipment. So you can see in the top right-hand corner here, that's the diagram of the setup on the left-hand side. And what I'm doing is I basically grab the battery and I make sure it's 1.6 and it shows itself to be 1.6 with a 1.6 battery, so I know everything's working. The voltometers are in parallel. Okay, so for the first one, we're just going to set it up as expected. Disclaimer that it's not actually 1 molar solutions for the zinc sulfate and copper sulfate, so that is a slight flaw. So we are expecting it to be 1.1 volts. The reason it's 0.8 is probably due to internal resistance. So in some mark schemes, they will actually state it. So when you're trying to get the expected value, which is 1.1 volts, there's internal resistance, which may be the reason why you're not getting the full voltage. Disclaimer, there's also a weakness in the concentrations. And so you can see there that I'm not getting the full voltage, just 0.8. Okay. The next system is a little bit more trickier. I'm going to reverse them. And you need to realize that this is galvanic, so it's spontaneous, so it's not electrolytic. We're putting energy in. We're always getting energy out, so it's always going to work. But you can still get a negative value. The voltometer is reading the analog and digital are both giving negative values because the electrons are going in the opposite direction. And so you just need to be aware of that. And so moving on to the next bit. Okay, so now I'm going to just test that now I've done a positive control, and so I know it works when it's meant to work and hopefully give 1.1 volts. I'm going to do some negative controls. And so this one, I'm just going to put water in there and see, so it shouldn't work. So all of these negative controls should read 0. And so that tells me I've already done it should work when it's meant to. Now I'm testing that it doesn't work when it's not meant to. So you can do positive and negative controls and calibration. So I've already done calibration, positive controls, and now I'm doing neg controls. And you can see I'm getting a small reading, which means there's something wrong with the system. So the fact is water, it still allows electrolytes to flow. So what I'm going to do now is weaken the system right even more by putting just water in there, but unfortunately it's a little bit contaminated, and so it actually gives quite a high reading as 0.55, and so my negative control is definitely failing here, and the system is not very good. It's not really a full neg control, so I'm just sort of improving the neg control by putting some water in there. It looks a little bit dirty. So what I do is I just pause the video and I'm going to clean the electrodes, clean out the beakers, clean everything. One thing I forgot to do was even just replace the electrodes as well. So I could have just replaced the zinc and copper with platinum or graphite, which is the C there, and that would have been a full neg control. But now at least I'm getting 0.05, so that's good enough. I could add that to my errors. So reverse it is still 0.05, so I'm not quite sure what's going on there. But that's close enough to a full neg control as far as I'm concerned, with a small error in there. Okay, so another thing that is quite interesting is people think that you need the salt bridge. So I'm just going to test that one out. And I'm just doing it with pure water. I'm just checking that it's there's no nothing else going on there, and it's giving a 0.38 volts. So compare that to putting it in zinc sulfate. Now, zinc sulfate means just like water, there's no copper to join up. The zinc doesn't really care because it can come out. It is slightly better. This one will be the best one because the zinc comes out into solution, so we don't need it in the solution, but the copper is in the solution, and you can see, if you're very quick there, you can see that the zinc is getting coated in copper. So it's actually even higher. And then when we dilute it, it goes down a little bit because the copper is diluted. All right, so eventually the whole thing wouldn't work because the zinc would get coated in copper, so the salt bridge keeps it clean. Okay, but it does work better for a short time.